Welcome to FCTV podcast. And my next guest here is Jason Eichenholz. Jason is a scientist, inventor, and serial entrepreneur whose work has helped shape technologies ranging from autonomous vehicles to cancer detection and space exploration. He's founded multiple high-tech companies, helped take Luminar Technologies public, and holds more than 90 patents. Now, as founder and CEO of Relativity Networks, he's focused on reinventing fiber and the future of connectivity. Jason, it's really great to have you with us. You're making optical networking cool again. I was a reporter for Light Reading like a million years ago, and you're making it sexy again. Is that what's happening?
We're trying. It's very simple. All I got to do is change the speed of light and
there you go.
Make it happen.
Yeah. So, all right. So tell me, what is Relativity Networks and what are you guys doing to revolutionize optical networking?
So we started Relativity Networks back in 2023, where we saw the need for better connectivity between data centers. Specifically, we saw a geographic concentration happening in places like the Bay Area, near Dulles Airport, Dublin, and we recognized the need for connectivity at the same time that my co-founder was developing a next generation of anti-resonant hollow core fibers for the Department of Defense.
Okay.
And so we merged those two programs and found a way to develop a hollow core optical fiber that allows light to move 50% faster down the pipe, which allows things to be 50% further away and yet be digitally still as close as needed.
All right. Okay. So let me stop here. So you're saying 50% faster. Like, you're not changing the speed of light. So what's going on there?
So we're not changing the speed of light. And, it's this theory that the scientist, I'm a scientist, Einstein had, Einstein's theory of relativity.
Right.
Which said the speed of light is c, basically 300,000 kilometers a second. In a traditional glass fiber, light moves down the pipe at 200,000 kilometers a second. So what we do is we go through an air core and we go at like 99.99x% the speed of light. So we move down the pipe at nearly the full speed of light.
Okay.
We recognize Einstein's theory of relativity. We got that question so many times. We named the company Relativity Networks just to be sure, yes, we understood we can't go faster than the speed of light. So now you have, think of it like an HOV lane or a pipe where the light moves down the pipe at nearly the speed of light instead of 2/3 the speed of light.
Okay. So does that change also potentially like the number of strands of fiber that you need, or?
It can.
Yeah. Okay.
So when you move from glass to air, not only do you go faster, but you can also put more power down. You're no longer stuck with the traditional aspects of an optical fiber.
Okay.
Optical fiber hasn't really changed since the 1960s. There's been 50 years of really incremental small changes. In fact, Dr. Kao got the Nobel Prize in 1961, not for inventing an optical fiber, but for getting the losses down.
Okay.
And you're at a fundamental limit where the losses can go. Hollow core fibers can have lower losses. You can put more bandwidth, more channels, and push them down the pipe. They have less nonlinearity, so you can juice up an amplifier. This is the single largest transformation to telecommunications in 50 years.
Oh, wow.
And you have that huge technology evolution here. And now you have this insatiable market pull for this AI revolution that has got this conference hopping, because it's the single largest transformation from a overall societal change with AI. So now you have a huge technology evolution and a huge market pull. This is the first time in my career I've experienced such a strong market pull for a new to the world technology.
All right. So how is this all related? Like, how is AI driving, or tell me about that marriage between this technology and AI. Like, what is AI doing that your technology is somehow going to Like, what problem is it solving
So
for the AI folks?
The specific killer app, and we're solving many problems,
Okay.
is connectivity.
Okay.
And specifically, the thing that our customers are demanding is they want to continue to bring data centers online as quickly as they can. But what people are beginning to figure out is there's now not enough power.
Okay.
There's a not in my backyard going on with where people don't want data centers. I think we're going to talk about that. We can go through all of these things.
Yeah.
But fundamentally, we are running out of places to put data centers closer to the other data centers that they need to connect to. In AI, the data centers, you can move up through a rack. There's something called move across, where the data needs to go from building to building or campus to campus. And that is a big part of what a hollow core fiber allows you to do. It allows you to go further in the same amount of time and provide that geographic optionality on where to go put the data center and to do it closer to where the power is available.
Okay, so let's talk about the power, right?
Yep.
Because I think that's one of the big things that everybody's talking about with data centers. It's one of the reasons why people don't want them in their communities. Like, it eats up so much power, requires so much power. So again, how are you guys sort of solving for that problem? You talked about, well, you just answered that question. Like, I don't get it.
So let's talk about it a different way.
Okay.
It's easier to move the gigabit than it is to move the gigawatt.
Okay.
So it's easier to move. People originally thought the use case for hollow core fiber was to go from New York City to Hoboken. You go across the river, the land is cheaper, all that stuff. That's not the use case.
Okay.
The use case is you may be able to go 10, 20, 30, 50 kilometers down the road, and there's a site that doesn't have people in your backyard. There is no not in my backyard because there's nobody living there. You can find that you can bring the power maybe a kilometer, not that 20 kilometers, which means you can do that in 3 months or 6 months, not wait until 2030 for the other site that you were considering.
Basically, it gives you the option, it sounds like to me, was what you're trying to say, gives you the option to plan the data center closer to where the power source is, or in some way further away from where all the people are that don't want it in their backyard.
Right.
Is that?
And
okay,
with enough land to put in solar farms with energy storage, and to put in the ability maybe to access wind so you can get more abundant water. There are a lot of headwinds that are facing people trying to build data centers as they look at the lack of power, the not in my backyard, the zoning, all of that stuff. What we do is we provide a tailwind. Think of it like a Rosetta Stone to look at the map differently and say, oh, with hollow core fiber, we can move a site here and still hit the latency specifications between these other two campuses or even inside a campus. So what we're doing is providing the ability to go further in the same amount of time and provide optionality for the hyperscalers.
Okay, so do you have any examples of folks who are doing this? Like, do you have anything, like any of your customers that you've seen?
Yes. So our customers really are excited about doing this.
Okay.
We started the company, and back in 2024, we did a proof of concept, and we've been rapidly working on scaling our production processes. We have a great partnership with Prysmian, who's a market leader in cabling and fiber. There's this overall lack of fiber, but we didn't start this. In fact, there's another company, Luminicity, that was acquired by Microsoft. Microsoft has talked about this for 2 years in a row in their annual
what have they talked about? Like,
they talk about hollow core fiber
really?
and
Okay.
how this is solving that exact problem.
Okay.
But when Microsoft acquired Luminicity, they created a vacuum in the market. And that gives us, as the only Western supplier, to go meet the needs with hollow core fiber to address the needs of all of the hyperscalers, as well as the telecom carriers that are looking to extend their metro edge. looking at 5G and 6G, where there are latency specifications. Anytime that you want to go a little bit further in a certain amount of time, this is where hollow core fiber sort of finds its natural swim lane.
Okay.
And so the hyperscalers see us as a solution to open up that optionality. And now they can take a data center, they can have all the GPUs, they can have all the contracts, all the customers. There's billions of dollars being left on the table with the data center site that they had to scrap. They can take all the equipment and the design of that building and move it to a different location. And that could open in 2028 instead of 2031. That's worth billions of dollars per year.
Okay. And you've seen this. This is happening already.
This is what our fiber is going to be deployed to go do. Yes.
Wow. Okay. I'm going to shift gears a little bit here and throw something else. So, as we've got edge providers and providers building out fiber, lots of federal money available to do that. So we've got all that kind of build out. And then you've got the hyperscalers that need all this fiber to build out their AI data centers and their data centers in general, because it's not all AI, right? Mm-hmm. There's a shortage, right? So, what is what you're offering kind of able to give customers more bang for their buck, or how are you guys addressing that, or how do you play in that shortage market?
So it affects us because we need to build the capacity to scale. As I said, we have a great partnership with Prysmian, and they are our production supplier in scaling. But at the same time, as we try to go retrofit fiber draw towers, now they can sell every kilometer fiber they can make 2 or 3 times over. So the opportunity is more than just the fiber connectivity. It's about the ability to have a specific outcome beyond the fiber. I've spent my career bringing photonics and laser and optics technology to market back from the light reading days. This is very different. This is, you can't do it any other way than to use a hollow core fiber. If you can do it with wires inside data center, you'd be doing it with wires and Cat 6 and Cat 7, but that's no longer the case. Now it's optical fiber because of the extreme amount of data you need to move. And as long as people need to move data from point A to point B, and they want to do it in the shortest amount of time possible, there's a use case, and that is despite the economics of the hollow core fiber being more expensive.
Okay. So, sounds like hollow core is just going to take over everything. Are you guys the only suppliers?
We're the only Western supplier. So there's a partnership with Microsoft, and then in September, Microsoft announced a partnership with Corning, and Corning is, from what we're hearing, is now captive with Microsoft as well. Microsoft sees this as a huge competitive advantage to be able to turn on all the data centers, and they were ahead of the curve. They saw Azure and they saw ChatGPT and OpenAI before most of us had. So they saw that need, and now everybody else is catching up to that supply chain, and we're the only Western supplier that can meet the needs of that at scale.
So do you see anything sort of slowing this train down in terms of the data center build outs and that kind of, you've mentioned this not in my backyard issue, right? And I think that there is some resistance in a lot of people's minds to having data centers. It kind of reminds me of the people thinking 5G is going to give them cancer. I don't want 5G in my neighborhood. Are you seeing that be a problem for the data center build outs? Are you guys worried that there's going to be any kind of slowdown at all?
So I thought there might be a slowdown about a year ago.
Okay.
And I was like, is this a hype? I went through the dot-com boom and bust. I've seen Gartner hype cycles. I'm always skeptical in this. And I'll never forget, I was at a Fortune Brainstorm conference in Park City, and I was listening to the president of Walmart talk about all the AI initiatives that they had going on inside Walmart. And I thought about it. I said, I wonder which one of those programs they'd get rid of. Right now, more than 50% of the internet traffic that moves around is related to AI and bots and all these agents running around gathering data. If we're talking about what my daughter uses to write her term paper using ChatGPT, I can understand the peak. But when I look at the positive things that are coming out of AI, and whether it's new cancer detection, new rocket engines, every day that goes on, I hear all these great stories of fundamental problems that are being solved with AI. And I look at the business use cases. I don't think that genie's going back in the bottle. And even if there was a slowdown, for us in those geographies like Dulles, where there's Data Center Alley, or San Francisco, other locations, we'd still be able to sell all the hollow core fiber we could make.
Are you guys able to keep up with the demand now?
No, it's, bringing new technology to market at scale is hard. And that's where we're really fortunate to have the technical prowess that we have of Prismian. When Microsoft started, they vertically integrated with the acquisition of Luminicity. I realized there was no way we could scale on our own to meet the insatiable market demand. If this was a 2, 4, 5 year timeline, yeah, we could have built factories, hired people, scaled. But I'm a big fan of partnerships and open innovation. And that's why I'm really happy to be able to partner with Prismian. And they, the phone's ringing off the hook, and we have to be very careful on how we allocate the fiber for the next couple of years to sort of seed the market as we bring our capacity online.
Well, I was going to say, is there a risk that that if there's a slowdown, it's because there aren't enough components or even people to get the technology deployed?
So there are risks and challenges to scaling AI, but it's not in the optical communication side.
Okay.
It's the transformers. It's the literally turning on gigawatts and gigawatts of capacity. I mean, if you look at the Susquehanna deal with Amazon behind the meter of that nuclear power plant, or you look at Microsoft buying 3 Mile Island.
Yeah.
When we were trying to convince investors to invest in Relativity in the very early stages, they didn't see the power problem. And then on the front page of the New York Times and the Wall Street Journal is a company like Microsoft buying not only a nuclear power plant, but probably the most famous nuclear power plant in the world, 3 Mile Island.
Infamous. Yeah.
Yes.
Yeah.
That tells you, now a different unit and all those things, but for the public, that's how big the need is.
Right.
And that's for AI. Now, but I also hear these not in my backyard scenarios, and yet somebody today is going to be watching this video tomorrow. They're watching this video on a server in a data center, and then they're going to be checking their Gmail or their Hotmail. They're going to be,
Hotmail, come on.
Hey, you'd be surprised. Or Googling something, using Google Maps, watching YouTube or Netflix. I don't see those going away anytime soon.
Right.
So if you're going to keep using Netflix and YouTube and Google Maps and Gmail and Salesforce, and you're going to go to an airline website to go book your airfare, the cloud isn't going away, and the demand is only increasing. So I think we've got some job security for quite some time.
All right. Well, that sounds good. Well, as we wrap this up, I just want to have one final question to give you the last word here. You talk about your company developing a technology that is going to revolutionize biggest technology advancement in decades,
15, yeah.
right? So what do things look like in 10 years? When we get back here and hopefully we'll be back at a show to talk about this. What are we going to be talking about? What's life going to look like in 10 years with this revolutionary technology?
I think the way people do work, I think the way that AI is going to reshape our society. I do think it's an industrial revolution scale societal change. I'm not smart. I'm not a futurist. In fact, we've got a talk by a futurist and physicist here talking about this stuff on Wednesday. I'm looking forward to hearing that. I think how we live as a society is going to be completely different. I've been through booms and busts. I went through this whole boom of self-driving cars, and it was going to change everything. And you go through that trough of disillusionment. Information will be at the tips of our fingers, so we're going to have access to, I think by then, AGI, and you're going to have intelligence to go solve problems. And the reason I unretired from doing philanthropy to start Relativity Networks is I didn't want to sit out the intersection of huge technology change and huge societal change. I wanted to be part of that. And I know our fiber will become ubiquitous in keeping that acceleration of the technology growing. And that makes me smile every day.
Well, that sounds really exciting, Jason. I mean, really, really cool stuff. And, I hope we get back here to talk about it. So
we will.
That's it from FCTV right now. And we'll be talking to Jason, hopefully. And I'll come back in 5 to 10 years and we'll have this conversation.
Done.
Okay.